Hey, what's up guys? Welcome back to yet another live stream. Here we go. The day we've all been waiting for. The highly mysterious Comet 3I Atlas. Newly released images. They're coming soon over here via NASA. Some of the images you're about to see are coming from the NASA or the Mars space probe. Other ones are coming from other locations that I'm not aware of just yet. But we're waiting patiently for the new update. What's up, guys? Good to see everybody here. Red Pill Tina, Free Truth. I am Hector DC. What's up, guys? Good to see you all here today. Are you ready? You want to see some new pictures of Atlas? Let me show you something. The reason I use this as the thumbnail is because some people, there's an article going around right now asking, could the interstellar object known as 3I Atlas be a life form? This is a new theory going around. A provocative new paper claims it's unexplained acceleration, which it did. All of us that are following this remember the day this thing accelerated, and keep in mind, it's moving at a staggering 130,000 miles per hour to begin with, and it accelerated. Nevertheless, its structural anomalies point to not a comet, but a cosmobiont. What's up, Milton Ray Williams? Thank you, buddy. A self-organizing plasma-based organism. You can't make this stuff up, man. It gets weirder by the day. Seriously does. Wanted to revisit some images by Michael Yeager. I'm going to share with you guys here in just a moment. Here's where it all began, guys. You're looking at an interstellar space view from, I believe this was the J.W. Webb Space Telescope, looking off into the vastness of space. Right there is where Atlas was spotted, right? Can you believe it? Way out there in the sea of stars, there it was, traveling towards the sun. Here it was when it was a little closer. Up here, I inserted this as it's even yet a little closer, swimming through the sea of stars, making its way into our little solar system. An interstellar traveler. This has only happened a handful of times. Look at the 5 tails that was recently discovered. Where's the one big tail? It's got an anti-tail pointing towards the sun. Some people are speculating that this is a way of refueling itself. And again, all of this now is speculation, but it's justifiable speculation because this thing is not behaving like a comet. Here's 1, 2, 3, 4, 5 different tails. Images here by Michael Yeager out of Austria, one of the best astrophotographers in the world. Here's another view. This one here is a standard view. The other one was inverted, black and white. But again, you should see, this is as it came out from behind the sun after perihelion on, I believe, the 5th. Where's the tail? It's got a few sprigs that aren't really going out that far. Just kind of looking at some photos that I've collected over the months of Atlas until we see some new photos, right? Here's the tail pointing towards the sun, if that's what you want to call it. Maybe it's a recharging mechanism. I'll show you guys the article here in just a second where there's a theory going around that this thing may be some sort of a plasmatic organism. I mean, like, again, you can't make this stuff up. You don't have to. Just look around. Here's the article right here. I thought that was pretty cool. That is one heck of an image right there. No doubt about it. Where are we at? I mean, this just gets wilder by the day. Here we go. This is over here at ibtimes.com. In the World and Science category, 3I Atlas is alive? ? New preprint claims object is a plasmatic organism? Article dated 11/18/2025 by Vinay Patel. Are you serious right now? This is what you call thinking outside the box. Wow. The interstellar object known as 3I Atlas has always been a mystery, and honestly, it still is. A recent preprint claims the enigmatic visitor may be a self-organizing plasmatic entity, a staggering possibility that a new life form is orbiting the sun. Listen, nothing's off the table right now. Even Harvard professors, one in particular, Avi Loeb, is saying nothing's off the table with regard to this thing. A cosmic puzzle is 3I Atlas, a living plasma. Scientific director at the Biotechnologica Exmol in the ResearchGate highlights that, where's this at? Oh, Rangel Martinez paper highlights that 3I Atlas exhibits several unusual features in its movement, appearance, and light signature, and I 100% concur with that. This thing looks nothing like any comet I've ever seen. And here's just an example of one of the comets that have gone through the solar system. This one here being a Comet Atlas. This is a different comet that was discovered by the Atlas facility. I mean, there's no mistaking what we're looking at here. A comet, right? A decent sized comet. And then here is one of the first views from the Gemini telescope on the Big Island of Hawaii of Comet Atlas, the one that we're following now, 3I Atlas. No tail, has an unusual color, not the classic green that we normally see. This thing has been unusual right out of the gate, and it has not changed a bit with regard to its perplexity. It's very, very interesting. Its path of travel, that's a whole nother topic of discussion, how this thing is traveling in like an airplane would fly along the ecliptic plane. That doesn't happen. They come in like this here on a high incline. And notice when a comet enters the solar system, notice right here how the sun always greets them, especially when they get too close to the sun. Listen, this is the sun's neck of the woods, and she defends her neck of the woods. Watch her start hurling CMEs at the comet. Hurled 4 CMEs. Here comes the 4th one right there at the comet. Undeniable. And that was a big comet with a very big tail. There's no denying what we were looking at there. It was a comet. This is an interstellar traveler from another star that has a different atomic makeup. Here it is again. This is another image by Michael Yeager from back in, I want to say, August? Again, no tail. No tail. We're pulling light. We're trying to pull darkness. Wait, here it is right here. Trying to remove darkness, which I did right there. You can see it kind of wobbling in this series of long duration. These are long exposure photos that are stacked together. That's how you have to do astrophotography. It's a lengthy process that takes a lot of patience, very good equipment, and skill. This man is highly skilled. To be able to pull this in at the many millions of miles away that it is quite impressive. But again, you know, there's no tail. And he even said himself, where's the tail? Where's the tail? We've been waiting for the tail, and it just never came. So, you know, you can't help but think that this is definitely something otherworldly, and it is otherworldly, obviously. It came from another star system. Absolutely it did. Here comes Mr. McNaught. Look at that. No denying that's a comet. Look at the big dramatic tail that was over 10 million miles long. Here's another one looking at Comet. Which one was that? I think that was Atlas back in January of 24, I think. Super huge dramatic tail. And then this is just a little collection of videos that I put together while we're waiting on the new pictures to be released. This is another close-up, fairly close-up view of Atlas. Here I removed a lot of the noise. I denoised this one big time because I was determined to pull forward a tail. If there was a tail there, trust me, you were going to see it. It's not there, man. It's just simply not there. Never has been. And people are looking at these images trying to, almost in a sense, manifest a tail on the back of this thing, you know? Just to make sense of it so we can like, okay, it's a comet. And then that's the end of the discussion. That's not happening. There's no tail on this boy. Right? Look at that. Not a chance. There's no tail. This is a highly mysterious object. This has only happened, I believe, 3 times in recorded history that something like this has entered the solar system that was at least known to man. And we've been able to record this thing, and we're about to see here very soon some new images of Comet Atlas. Here's another article. We're just talking about some new things until the images are released. Spaceship, they're calling it a spaceship. This one here calls it a living plasma. I mean, you know, the theories just go on and on and on. But at the end of the day, you can't blame people for thinking outside the box, and I encourage people to think outside the box. Be a thinker, man. Interstellar Object 3I Atlas, also known as a spaceship that has gripped scientists worldwide, is set to make its close approach to the Earth next month, according to a Harvard professor. The mysterious object has routinely split expert opinion, and there is a wide variety of opinions about this thing, a wide variety. Starting off with the Harvard professor Avi Loeb, I believe is his name, how you pronounce it. He said from day one that this thing was not a comet. Let's look at some of these other images here. It's kind of browsing through some images till we're waiting on the release of the new photos. And hopefully we get the originals, right? I didn't put that in there. I don't know who did. Okay, oh, there you go. This is an artist's conception of Oumuamua. Remember this one here that came through the solar system a few years ago? Was behaving unusually, and if I'm not mistaken, it had some sort of an acceleration event as well. I don't know. This stuff is getting really wild. This object here, extreme polarization, according to Leb. I believe that was, what was that, Oumuamua? I'm not sure what that one is there, guys, to be honest with you. These are just some articles that I ran across to give us something to look at until the photos are released. Come on, guys. We've been waiting patiently for a long time. This thing went by Mars a few weeks ago. And in fact, when it did go by Mars, let me show you guys if I have them. Wait a minute, do we?
Good afternoon, and
Here we go.
welcome to NASA's Goddard Space Flight Center. We are live today with NASA experts who are excited to share the latest images we have of the interstellar comet 3I Atlas.
I got you.
3I means third interstellar, and Atlas refers to the NASA-funded Atlas Survey Telescope, which made the discovery. We are joined today by Amit Kshatriya, NASA's Associate Administrator, Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, Sean Domagal-Goldman, Director for the Astrophysics Division, and Tom Statler, Lead Scientist for Solar System Small Bodies in the Planetary Science Division. We'll be taking questions from the media on the phone bridge and through social media, but before we get started, let's learn more about this fascinating comet and share some images. Amit, kick us off.
Hi everyone, America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about what how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars, from our amazing machines that have been roving the planet for 30 years to look for those things. That is something that's really important for us to learn about and discover. It could be an amazing discovery if and when we can confirm that. But 3I Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail. But just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance Orbiter, taken on October 2nd as the comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3I Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the Comet, which is shed by the comet as it continues its trajectory towards the sun. I'll leave it to my esteemed colleagues to share further details, and I'd like to introduce you to the head of NASA Science, Nikki Fox.
Thank you so much. It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs. And by studying them, we can learn about the environment from, basically where they formed, where they came from. This one came from a different environment from our own. And so we're already starting to see some really interesting differences to comets from our own solar system. 3I Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries, just like this one. Right away, of course, NASA's Planetary Defense Coordination Office they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our sun. On October 30th, the comet itself reached the closest it will ever be to the sun when it crossed just inside Mars's orbit, which is why the image that Amit just showed, he noted it was the closest instrument physically to the comet because the comet was right inside the orbit of Mars. Earth was on the opposite side of the sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the sun from where the Earth is. However, it was also clear that its positioning behind the sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system. And boy, were they ready for this event. NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask, and this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3I Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. Now, what James Webb did, and its companion Sphere-X, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations, with James Webb and Sphere-X, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we'd usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just, to put this in context, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system, and that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed to higher levels of radiation than comets in our own system. Or, as I said before, it could be that the comet just formed from a region where carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it once we knew where it was. Now that the comet is near, relatively speaking, our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw in the animations while Nikki was speaking, the sun, of course, is at the center of our solar system. The planets are orbiting around the sun, and in this case, Comet 3I Atlas has come through on a trajectory in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big, Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that shared Jupiter's orbit around the sun, called the Trojan asteroids. Lucy was 240 million miles away from 3I Atlas, which is circled in the center, when its high-resolution LaLaurie camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I Atlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN, has looked at the comet and also split up the ultraviolet light according to color. So you're seeing 3 different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from Comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. The answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. Doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, of solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of the data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point. It's natural to wonder what it is. And we actually love, as Amit said, we love that the world wandered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But we were very quickly able to look for sort of the easiest thing to do. I'll put it in a different way: is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any techno-signatures
Okay.
or anything from it
I can't take
that
any
would
more
lead
of
us
this.
to believe it was anything other than a comet.
No,
but the
I
super
can't do
cool
it.
thing is not.
Sorry,
that
I
it's
can't do this
exactly
anymore.
like all the comets that we see in our solar system.
I can't do
It's
it.
the differences
No.
that are so tantalizing for
No,
us.
I can't do it. Guys, I can't take any more of this here. I'm sorry. This is totally based off the pictures that they just shared. We're supposed to believe that, oh yes, this is behaving like a comet, looks like a comet. No, it doesn't. The pictures y'all just shared were terrible. I've seen better pictures with a 5-inch telescope from down here on the Earth. That was sad. Unbelievable. Here's some photos from back in, October? Look, there's October from the Earth. Come on, man. Those were the worst pictures of Comet Atlas I have seen yet to date. Here's some newer pictures from, November? Yeah, 3I Atlas. There you go. Look at that. Gentleman out of Colombia, November the 8th. Look at that. They didn't even show anything this good. And they've got the big equipment. This guy took this from the ground. I believe he was using a 14-inch, which a 14-inch scope is pretty good. But you got to keep in mind, he's down here on the Earth. Look at that. That was, this image right here is 1,000 times better than anything they just showed us. 1,000 times better. But yet they're discerning from the images that they just showed us that it's acting like a comet and behaving like a comet. And better images like this one right here that was taken less than, 2 weeks ago? Are telling a much different story. This isn't behaving like a comet, and it barely looks like a comet. Man, after a while, you just get tired of the spin. You really do. It's just a constant spin cycle. Constant spin cycle, man. This thing has a deep-seated mystery behind it that they just simply don't want to talk about. I don't mind talking about it. I think it's great. This is something that's highly mysterious. It doesn't behave like a comet. Just admit it. Come on, man. That's embarrassing. No, this doesn't behave like a comet. There's no big tail. So anyway, these are better images here than what they just showed. I was expecting something really, really good, but I should have known. I should have known they'd let me down. I knew it, but we had to show up anyway. I had to just see if maybe they were going to show something a little bit better. But like I said, we've been looking at better images for several weeks. I don't know what that was right there, but here's another view of Atlas. This is from several weeks ago. Look at that. Did they show anything that even looked close to that? No, nothing even close at all. Terrible. But they discerned from the images that they just showed us, they discerned that it was a comet. Looked like a dust particle to me, what they shared with us. Wow, that was terrible. Unbelievable. Oh, well, anyway, guys, thanks for stopping by. What's up, Drew? Yeah, they never explained why no tail. Yeah, they never brought it up, did they? Totally avoided the elephant in the room. The elephant in the room here is where's the tail? Didn't want to talk about that, but it looks just like a comet and it's behaving like a comet. But coincidentally, this comet, for whatever reason, doesn't have a tail. Good grief, man. I don't know. Very, very disappointing. Anyway, guys, the photos that we've been looking at are much better than what we just saw there. In fact, here's another one right here. You can see it. This was 2 months ago. Look at that, 2 months ago from down here on the Earth. And they've got space-based equipment, and all we can see is a little speck. That was sad. That really was. All right, guys, thanks for joining me today. I'm hanging out on your Wednesday, and as we've talked about, we talked about it on Monday. Friday is right around the corner. And once again, I wanted to share this image as they were talking about, oh, we don't know where the comet came from, and they probably don't. That's about the only part that I believed. But here's where it was first discovered out in interstellar space. Way back here, deep amongst the sea of stars. Isn't that cool? Here it is up closer. And again, they didn't even show anything that good. That's an image from just a few days ago. So again, very, very disappointing. Wow. All right, guys, listen. Thanks for watching. Have a super day. And as always, be safe out there.